So now the water is closing the circuit.
A program called Thonny, a very basic program, Thonny, to program this Pi Pico. And it uses a language called Python. This is all that you can see on the Thonny screen. Now just look how simple this little program is. You may never have programmed before, and this is in fact who my target audience is. So if you have this hash, the 4 hashes there, this means it's like a rem statement. You can write anything you like, the program will ignore it. So this is a rain detector siren.py or main.py. This is the name that you can call it. Pin 15 goes to this piezo speaker, pin 16 goes to the water switch, rain closes the switch to turn on the siren. So this is all just whatever you like to explain it to yourself, you do it. Now you have certain routines, import machine, from the machine import real-time clock. Now import machine, I'm not an expert, I've only just discovered this Thonny and Python. I love the language, and I'm just basically monkey see, monkey do, copying certain routines. Import uTime means you can now use time, like you can get it to pause for a second or parts of a second. From machine import pin. Okay, so you're going to, from the Pi Pico, you're going to import a pin. So here's some more, just writing to yourself. This is a rain detector siren program. This program detects rain and makes a siren sound. Okay, so all of this with a hash next to it, the program just ignores. Now here I've called button rain. I could have called it on off switch. I could have called it anything, button dash or underscore rain. This I again copied from another program. From the machine, pin 16, comma, it's an in pin, meaning it's going to detect a signal coming in this case whether the switch is pressed or not by the rain is going to close the circuit, and it's going to have a machine pull down, and there's a closed brackets there. So you can see the syntax is quite easy. Then the siren, or I could say the speaker, is on pin 15. So I call pin 15 siren, and it's an out pin. So it's going to send a signal out to make a sound. Pin 15 is the switch, the siren on pin. Now, here comes my main program. While true, colon. Now notice there's very little punctuation in Python. Import time. If I'm not sure even if I need that importing the real time. I don't need the time. I could probably leave that line out. If button rain, remember that was, we called button rain somewhere around here, there is pin 16. If pin 16 value equals 1, meaning the switch has been closed by the rain. So if I could have called this anything I wanted, its value equals 1, colon. So now, okay, look at the syntax there. You basically just have to copy it and use it. But it's not that difficult syntax. You just copy it and use it till you get used to it. Now we use a for next loop. For frequency in the range 1 to 225,000, colon. Siren, that is pin 15 is high. Seems to need those brackets because it's a function or something. On time equals 1 upon f. So now f is going to start from 1, then it's going to go to 2, 3, 4, 5, 6, all the way to 25,000. So we've got 1 upon 1, which is 1 second, 1 upon 2, which is half a second, 1 upon 3, which is a third of a second. And it's going to, in each of these cases for f, it's going to do the following. It's going to be on for that time, then it's going to leave it on, meaning sleep for that 1 upon 1, 1 upon 2, so on. Then it's going to switch it off, and then it's going to sleep for the same on time. So it's going to be on for the same time as it's off. I could have said off time, but let's just use the same variable. And that's all there is to it. Now look at Python. Look how nice it is. So here's our main program. It's just going to keep on looping through this program indefinitely. And Python uses indentation. So all of this is done, will do all of that that's indented within it, and all of this that's in here will do all that's indented. So this is like the most busy, then do that if the for is called, then do that if the if is called. Now, and then while true is the most indented. So while true, and nothing turns this to untrue, meaning while true is just there to make the program loop indefinitely. We import the time, we check the rain button. If it's 1, then for 1 to 25,000 times. So the computer's going to do this 25,000 times. It's going to switch the siren high. It's going to leave it on. It's going to turn the siren high. It's going to leave it on for 1 upon f time. Then it's going to sleep and leave it on. Then it's going to turn the siren low, and then it's going to sleep while it's switched off. And so this on, off is going to create the siren thing. Now, here is what I think is the problem, why it takes the siren so long to get started. So we're going to start at sort of a frequency that humans can hear, let's say about 16 hertz. So instead of having it wait 1 second, I'm going to change that to 16. Now to get this to program and run, I'm going to now go to the Run Current Script button, and it's going to now have saved it, and it's going to run it. I could also just let's see if QuickTime Player will allow me. No. I could also save the file and then run it, and then it's going to hopefully work better. Let's try that now. Single transistor audio amplifier circuit, and on theorycircuit.com/simple single transistor audio amplifier circuit, I found this little circuit. So it's got 9 volts. I guess it would work on even less. It's got a speaker, they say 8 ohms, so maybe we can just find that out of an old radio, or just a speaker lying around, or even headphones or something like that. I don't think these values matter. I think it'll work on 5 volts, whatever ohm speaker you've got. And here you see this little arrow pointing out an NPN transistor, BC547. I think any NPN transistor would probably work, but we'll see if we can find a BC547 transistor. There's the collector base emitter, and there is a capacitor and a 2 kilo ohm resistor. So it's only got 1, 2, 3, 4 components, and this will go to the negative side of the battery, that will go to the positive side of the battery. Here will be the 2 inputs from our Pi Pico. This will be to the ground of the Pi Pico, and this will be from the pin out, which is pin 16 of the Pi Pico, will go in here. And when we combine the two, we're hoping that we can get a slightly louder siren. So all I've done is Googled it. Now I'm going to go and look for the parts, get them together, and then let's see if we can make a little siren. So let's try and do that. Let's see if we can build this audio amplifier circuit and add it to what we've already got and make a much louder siren. So here I did a Google search for BC547 transistor pinout, and here it shows a picture of the transistor, and it says this is collector is 1, base emitter. So that's the order. If this is the flat side facing you and the circular side away from you, the pin on the left is the collector, base, emitter, CBE. So let's remember that, so that we can arrange them according to the circuit diagram. So I would suggest you draw this and write it down and get yourself a little diary. And if you're going to use this transistor, do yourself a favor and draw it, all that you see here, because you're going to, everything you learn you want to remember. You don't want to have to keep looking it up each time. So draw it, and then when you finish your project, you will have on the printout of your program, you will have drawings of your transistor and the pinouts, and when it works, you're able to rebuild it.
The idea is that when these two leads get wet, so this water is going to act as the switch. Okay, it did work. Let's touch those two in the water. I can hear it started up. So the water is acting as the switch. Well, I'm trying to make a rain detector, something that will sound an alarm when it rains and wake me up. You can see it's got many problems. The first and most obvious problem is it's too soft. The water does seem to work. And then there seems to be a whole long period of time when you hear nothing. So we want to get rid of that. And that's part of the algorithm that we programmed this Raspberry Pi Pico with, that we need to improve the algorithm. So we are making something that will, when it rains, wake you up, because in my case, I run out and I start harvesting water off the road, and I channel it into my fish pond and store it for gardening. So rain comes at, say, 2 in the morning when you're fast asleep and you want to know about it, so you can run out, get your pipes organized, and catch the rain coming off the road. So this is what we're doing. We're making a rain detector with a siren to wake one up. Now I changed the frequency in Thonny, and notice how the siren starts up much quicker. So I've got a bags of resistors, and the closest I could find for now was a 1K5 or 1,500 ohm resistor, which should do fine, because I see some other circuits use a 1K. It doesn't matter, I don't think, exactly what you use. So we found our resistor. Now I've got boxes and boxes of transistors which I have collected over the years, and these are the BC547 NPN transistor. I've also bought in mass all these different transistors. Now all of them have just slightly different properties. So I could have used almost any of these that are an NPN one. It's got a little sheet here, NPN, NPN. So I could have used any of these NPNs instead of the 547. And here I've written emitter base collector, the order in which the pins are. I don't remember for this 547 the order, so I'm going to have to Google it. So we found a transistor. There it is. It's got 3 little legs. So we found our resistor, we found our transistor. So there's the resistor, the transistor. And then again, over the years, I've collected boxes full of capacitors, or bought them. So here's a 47 micro capacitor. So there we go, that one's being used. You can see the legs are all bent, and so that is a 47 micro. I will check it, and we've got all different values. So it helps to have built up a collection of, these are the big resistors here, bags of small resistors. So I've got my transistor, my capacitor, and then I've also got, just to get a resistor out of this bag. These little bags are sometimes quite difficult, and you just want to tear the whole thing open, but you've got to restrain yourself. Just to get it. And there is our 1.5K resistor. Now we need to put it into a base. Let's find a base. So I've got a whole box of these little bases. And what color do we feel like? I generally like the lighter colors because I'm colorblind and I find it quite hard to use. But anyway, and I think you would be able to see it better if we used a yellow, or a green, whatever color. I'm colorblind. So let's just take those components out and use this. I take it it's either yellow or green. And now we just have to look up this BC547's pin out diagram. Now when I've connected up the amplifier, I'm using a 5-volt brick. The same speaker, there's our little amplifier circuit. I've also got set the LED to flash. It's not making perfect contact. There, it's working with the amplifier circuit added through the same speaker, same piezo speaker. It's a little bit louder. So what would happen if we substitute, say, a headphone speaker for this little piezo speaker? Let's see if it's just a touch louder. Nothing's fixed together or soldered together, so it does get a little bit. So let's try it with let's take out this speaker and try it with a headphone speaker. So it's a bit louder. So that's probably the speaker I would favor to use. So now that we've got our circuit working, we could neaten it up, solder all the joints and make sure that it doesn't fall apart or have any loose connections. But that's almost loud enough to wake a sleeping person. I've just set it to work continuously. These are the two leads that you have to touch. Let's just touch them, and then it starts off. So now our amplifier and our headphone is working fine. We just have to make our water switch. So to make our water switch, I'm going to take a milk bottle, I'm going to cut the top off to make a funnel. I'm going to put the funnel inside there to catch the rain, and now all I have to do is to glue 2 wires to the inside of this lid, and then when water falls in there, it's going to close the circuit. This lid will go inside here, so our 2 wires will come out and go to our circuit. So let's do that. Let's glue 2 wires to the inside of that lid. So I found a long piece of wire. Remember that this has got to be out in the rain, and I just stripped off the ends, and now we're going to take our glue gun. I just sanded that a tiny bit. We're going to take our glue gun, put a dab of glue in the center, so there's the glue in the center, and we just stick that in there with the ends pushed apart. So that's now our water sensor. Okay, but first we have to pull our wire, which is going to go through here. So we have to pull all the wire through. This is for our water switch. So our water switch is going to, we now put that onto its milk bottle, and in fact, to make it stand, I'm going to get the base of the bottle. Here is the base of the bottle, and put that in there, so that's going to stand like that. I'm going to just staple that in. So that's now stapled in there. So there is our water switch. Now we're going to place the 2 leads where our old leads used to be. The one went to pin number 1, 2, 3, 4, 5 along, which is that one. And the other one went to the end. So there is our leads in the right place. Now, we don't like to mix electricity and water, but let's pour in some water and see if the sound comes on. So now the water is closing the circuit. There's the water has closed the circuit, and it collects through this funnel all the water from this whole large area. So even if there's a few drops, it should close the circuit. So there is our circuit. All that has to be done is made slightly more permanent and prettied up a little bit. Now I want to say something. Let's just see if we can pour the water out and get this thing to stop. So I poured the water out and that stopped. I want to say something, that one should celebrate one's victories in life. Life is too short to go without celebration. So having been able to build an amplifier, to program this Pico, you know, no one's going to think anything about it, but I think you should pat yourself on the back. If you manage to do something, you figure this all out by yourself, you got to think, I am so fantastic and I am so great. I am a real hero in my own eyes that I managed to get this all to work together. Only 1 in 1,000 people would be able to do this. 1 million? Who knows? Not many people. Perhaps a handful of people, those who know something about electronics. And this was a fairly simple but lovely project to, just as an introduction to using a Pi Pico, which is a little microprocessor, and a few components to make yourself a little audio amplifier. So celebrate yourself in every achievement that you make. No one else is going to do it. Everyone else is going to feel much happier dragging you down and criticizing you and saying you're useless and worthless. And I'm writing my book on how to never feel guilty or inadequate, and see yourself as a hero. Everything you've done to make this project work, wow, it's fantastic. I celebrate myself. If that makes you feel bad, think about it. You should celebrate yourself in all the wonderful things that you're able to do. So let's just pour water back into this, and we will celebrate that this works. There it goes, quite loud enough probably to wake me.